All right, so we're doing section 13.9, number 18. So we have this trapezoidal trough that we're making this by bending up the edges of a 30 unit sheet by some angle theta. So these sides are x, and extend this out. This angle is theta. That's 30 minus 2x. Like we talked about in class, this is x cosine theta and x sine theta. So this side is going to be 30 minus 2x plus 2x cosine theta. So I can write the area as 1/2 30 minus 2x plus 30 minus plus 2x cosine theta times the height, x sine theta. I'm going to combine like terms. I'm going to distribute, get everything together, and I finally get that area equals 30x sine theta minus 2x squared sine theta plus x squared sine theta cosine theta. I'm going to take my partial derivative with respect to x now. A sub x. When I take that partial derivative, I get 30 sine theta minus 4x sine theta plus 2x sine theta cosine theta. And we want that equal to 0. And I'm going to take my partial with respect to theta. A sub theta, when I take that partial derivative, I get 30x cosine theta minus 2x squared cosine theta plus x squared. And when I take the derivative of this, I get minus sine squared theta plus cosine squared theta. And we want that equal to 0. Now what I'm going to do here is write sine squared minus sine squared theta in terms of cosine squared theta. So I just have one trig function in this. So I get a sub theta is 30x cosine theta minus 2x squared cosine theta plus x squared, and when I simplify this, I get 2 cosine squared theta minus 1. And we want that equal to 0. Let me grab these. I'm going to put these onto the other page. Back. What did I do here? There we go. So there are my partial derivatives. We're going to use the top one here and the bottom one here. When we want to solve this equation, so a sub x equals 0. When I'm going to factor out a common factor of 2 sine theta here. So I get 2 sine theta times 15 minus 2x plus x cosine theta equals 0. Well, this first term, 2 sine theta, if that equals 0, then our angle theta is 0. We don't want our angle theta to be 0. So we want this piece equal to 0. And so when I solve that, I'm going to solve that for cosine theta. I get the cosine theta equals 2x minus 15 over x. And now I'm going to look at this equation, and when I'm going to substitute this expression in for, or this expression in for cosine theta. So in a sub theta, when I substitute that in, I get that 30x times 2x minus 15 over x minus 2x squared times this quantity, 2x minus 15 over x, plus x squared times twice this quantity squared, 2 times 2x minus 15 over x squared minus 1, and that all equals 0. So now I just have an equation that only involves x, and this will let me solve for x. So I'm going to simplify this a little bit. When I simplify this, I get 30 times 2x minus 15 minus 2x times 2x minus 15 plus 2 times 2x minus 15 squared minus x squared equals 0. And when I distribute and combine like terms, expand this piece out, I end up with 3x squared minus 30x equals 0. And this gives me that x equals 10. Substitute that into this piece. So cosine theta equals 1/2. So theta is 60 degrees. So we fold up 10 units on each side, and we fold it up at 60 degrees, and that's going to maximize our area.